So Victor, I know that sneaked into some of the workshops today because I saw you like lurking into what is your thoughts on all the stuff that happened today already?
That was great. It was not deliberate lurking. I was just working beside Edina, and I heard a question which I could answer, so I chipped in. Yeah, I think it's a lot of great stuff happening. I'm really proud of the team with delivering the beta. It's an amazing achievement, I think.
Okay, so let's dive in. I know I've been asking you this question, but as you know, you will probably have to explain certain concepts again and again and again. Um, can you please explain again the world computer and what is Swarm's role in that?
Yeah. Yes, so the word computer. This notion came with the rise of the of Ethereum as the Turing complete blockchain. Basically, the founding fathers of Ethereum already imagined the Ethereum public blockchain as just one component of a holy trinity of components, which uh, kind of represent or mm, realize the word computer, that as they call it. The word computer is supposed to be the global infrastructure, the operating system of the World Wide Web. It's global computing infrastructure in which the blockchain is supposed to be standing for the CPU, the central processing unit, providing the global secure and consensual computation. But it also needs to have, in order to provide a proper computational framework, it also needs to provide data storage and data access like a normal local computer on the hard disk, and provides inter-component or inter-node communication services the same way as signals go from one subcomponent of a local computer to another. So in this sense, Swarm aspires to be the global execution environment for web applications. And yes, you heard it well. It aspires to actually provide a full Web3 stack, provide a backend to Web3. And if you think of the Swarm as the operating system of the new World Wide Web, the re-decentralized web, as it were, uh, then you have to think of Swarm as the whole ecosystem, the whole tooling that makes this web stack potentially possible. And what we're talking about when we're talking about the B client is in particular, or the Swarm core, it's you can think of it as the kernel of the operating system. So it provides the primitives and primitives of the building blocks of the execution environment.
Yeah, thank you so much. I want to focus a little bit on, we have these three components, so I'm going to just repeat them. Processing, which is the blockchain, and then we have storage, and then we have the messaging or communication part. It seems to me that one of the bigger things that is happening right now with Swarm is that we actually also are doing this communication layer. Can you talk about that a little bit? Because I always thought like this is Whisper, right? In the Ethereum ecosystem,
Yes,
Whisper is the... And I think I lost your video, but I'm not sure what's happening.
So yeah, originally as the Holy Trinity was conceived, like Swarm was considered the component for the hard disk of the world computer, and Whisper was meant to be for dark messaging. However, Whisper didn't really happen in many ways. I mean, it kind of stopped its development, and Swarm came to fill in that gap, and basically put up an ambition to realize the entire vision of the world computer, in the sense of extending the Turing complete blockchain to this global computer environment. And communication is a very important component in this, and kind of ironically, the way we hit upon the solutions for private and untraceable communication is almost serendipitous. It seems like it's one of those events which oftentimes happen with Swarm, that a solution to an unexpected problem fell out of the initial elegant and good design. And the same story happened with communication. We have two particular features which we will in detail talk about in the feature section. One is the single owner chunks, which allows feeds basically of chain mutable content and temporarily associated temporarily sequential data from a single user, and that can also serve as the basis for a double communication channel. And the other component is PSS, which is the untraceable node-to-node messaging.
Okay, I'm sorry to just interrupt for a second. It's a technical thing, but because we split the video and the audio, we will have an issue in the live feed. We don't have video for Viktor anymore. So if we could go back to the previous view, that would be really cool. Also, but let's just continue. Viktor, if you feel up to it, can you please, so we are talking about two topics if we speak about communication. One is PSS, or PST, as we call it, and the other one is feeds. Can you first talk a little bit about PSS and how did we make, communication happen over a storage network?
Yeah. So the interesting thing about the so one friend of mine told me when he read the Book of Swarm, which contains like a very detailed explanation of and specification of these components, he asked me like, "Oh my God, are you not afraid that you expose this great technology and maybe other competitors will just use that and cherry pick this feature and then go run with it?" And the funny thing is that's when I really realized that in order to realize all these features of PSS, you really need Swarm's basic design, the so-called disk model, which we introduced during the alpha event. So it's a distributed immutable storage for chunks. It has various important properties, which all are needed for PSS to work. So PSS is the postal system on Swarm, postal service on Swarm. Basically, the idea is here that you disguise messages as chunk traffic, which is transferred through relayed via nodes to the network in order to arrive at a local destination where they are stored. So they kind of, you cannot distinguish a message from say a piece of chunk from your encrypted family album, and that's why the messaging is completely untraceable. Due to the forwarding nature of routing, so that pieces of data are passed around via a sequence of forwarding nodes, it also provides ambiguity of the origination, so and therefore kind of anonymous. And of course, the whole thing is encrypted asymmetrically, which means that you can completely obfuscate both the content, the receiver, and the topic. And it can serve as a node-to-node messaging, which is completely untraceable. And has a lot of applications. So for example, it can be used as the initial key agreement exchange for subsequent private chat, similarly to a component in the signal protocol. Or you can use it for all kinds of push notifications in the network. So it basically provides a primitive that's completely new and allows for a new paradigm of building application backends on.
Indeed, I think it's a really exciting new thing. If I can, it's basically so that even a node operator doesn't know that a message has passed through his system. So it's really not censorable because you don't even know that a message has been sent.
You cannot know.
Which is sort of brilliant. So the other big thing is single owner chunks, which result into feeds.
Yes.
Can you talk a little bit about feeds and why we should use that?
Yeah, so single owner chunks as a basic concept is a strange kind of animal. So normally Swarm, the basis of Swarm on the level of disk, Swarm is basically a chunk store, and chunks are fixed size pieces of data with their address being normally with content address chunks. The address of a chunk is deterministic from its content based on a hash function. special hash function that we use this for. So that means that one bit is changed, then the data address changed. That means complete integrity protection. Now, single owner chunks provide a little bit different integrity protection. It's integrity protection protected by the signature of their owner, and the addresses are legitimated by having a kind of pre-agreed addressing pattern, addressing scheme, which means that if you hash a certain ID with the public key, then you get an address which you are entitled to write in. So it's like as if part of the address space was allocated to individuals owning a public key, and therefore the integrity, the signature that you can only do with the possession of your private key can provide validation and integrity protection to that chunk. And using this method, basically single owner chunks can provide the means to for example, define like sequences, like define a potential feed where a single owner can post, say, temporarily sequential but related content or regularly updated material or any kind of truth, be it like a Twitter feed or just subsequent say you can even represent the blockchain with it.
Yes, but please don't go there yet. I think this is a perfect topic for the Ask Me Anything, Ask Me Anything section later in this program. I only have time to ask you one more question, so I'm looking at my list, which would be the most interesting one. I think this one would be interesting. So you have said about Swarm that it's GitHub meets AWS.
Yes.
Yes, explain that, please, because it sounds so exciting. But
yeah, and I recently tried to coin a term for that. I mean, this is a bit experimental. Try to coin a term like open resource, this paradigm, which kind of capitalizes on the recognition that the open source movement, so being able to fork and modify code, unleashed an unprecedented improvement in the security, stability, and feature set of software applications. So the fact that you can leverage an entire open source developer community, and therefore like GitHub and the likes, plus the notion of open source on the social side, really brought a big revolution. However, it still left one bottleneck in a story that would allow that would enable a truly adaptive and user-driven adaptive development for applications. And that bottleneck was the fact that even that you can modify code in order to touch the same user base and or even deploy your modified code, you still had to go through a centralized bottleneck. Basically, a single gatekeeper was the company that operated that piece of software, especially if you're talking about like networks software. And with Swarm, this era is gone. So with Swarm, we really want to provide a global execution environment. So basically, a permissionless deployment environment for fork dApps. So you cannot only fork code now, but you can fork whole applications. And basically, in the same sense as Yogi mentioned in the My Data World, applications would just connect to your personal data, and also with your identity, the switching cost would be relatively zero. So it would, I predict that this would probably start a Cambrian explosion of different dApps and how the different dApps combine and how they are developed. Because basically with Swarm's zero cost hosting, so you can transfer the cost of deploying an app to basically your users, which means both automatic scaling and also less upfront capital investment to start businesses, which is an immense change in social circumstances.
Victor, I feel like I'm 7 years old again, and my mom is calling me inside and tells me that I have to stop playing outside with my friends because Miha, our stage manager, is asking me to round this up because we have so much more to talk about with so many more people.
Okay.
Let's continue this conversation, please, at a later stage, because it's so interesting to see how like a JavaScript library could actually make money for a developer. Thank you so much, Victor. I hope
Thank you, Misha.
I want to see you again in the AMA later, of course.